Now here in this example we have a really tricky question because we have our unknown x in the denominator, but it is also a separate sort of term in its own right. So how can we actually address this question? Now we notice that this here is basically, the first part is a division, because we've got a fraction, and then we have a subtraction. And we make use of our knowledge of the inverse mathematical operations, and we discussed that previously. So the inverse operation of negative would be a positive sign, a positive operation, the inverse would be negative. If we've got a multiplication, the inverse mathematical operation would be a division, and likewise the division would be, the inverse would be multiplication. So what we can do is actually quite a neat trick. We can actually substitute this expression that we have got here in the denominator, and we can just simply say we give this a name, another variable. Let's just simply call it y. So we've got y equals negative 4x minus 3. And then we can write this into a little bit more a form that we are already used to. So we might have negative 18 divided by y, because we've substituted it, minus 2 equals negative 18. And that is something that looks a little bit more easy to deal with. Now what we can do is we can bring this negative 2 to the other side, and what we do is we take both sides, the inverse mathematical operation. So we've got minus 18 over y minus 2, and the inverse mathematical operation, we have inverse negative, so that would be plus 2. So we have here negative 2 plus 2 equals, and we need to do to the right hand side what we have done to the left hand side, so we have plus 2. And what we see is that these 2's cancel out. So on the left hand side we've got negative 18 over y equals negative 18 plus 2, and that gives us negative 16. Now what we can do is we can multiply both sides by y. This would be the negative or the inverse operation of this division. So we've got negative 18 times y over y equals negative 16 times y. We see the y cancels out, and we have negative 18 equals negative 16 times y. Or we can also write this as negative 16y equals negative 18. And what we can do with this now is we can divide it, because that is a multiplication. We divide it by the factor that's in front of the y, by negative 16, and we get, let me write this here, y negative 16, y over negative 16 equals negative 18. 16 cancels out, the negative 16 cancels out here, and we've got y equals, well, we can put that into fractions, negative 1 times 2 times 3 times 3. divided by -1 times 2 times 2 times 2 times 2. And the -1 cancels out, the 2 cancels out, and we've got 9/8. So that is our y. But remember, we substituted it. So what we need to do is now we say this y, that was actually, I make a little bit more space here, that was -4x minus 3 equals this term 9/8. That's this fraction. And now we really need to figure out what is this x. So this was what here, this was our y term that we substituted right at the beginning. So how can we do that? Well, again, we use the inverse mathematical operation of this -3. So we do +3, and we've got -4x minus 3 plus 3 equals 9/8 plus 3. And the 3 cancels out. Now, let's figure out what this fraction is. We have to bring it to the same denominator. So we can write 9/8 plus 3 times 8/8. Then we've got them on the same denominator, equals 9 plus 24/8. And that gives us 33/8. So we've got -4x equals 33/8. Now we've got a multiplication. We do the inverse mathematical operation. We do divided by the factor -4. We've got -4x over -4 equals 33/8 times -4. And what we see is that the -4 cancels out. We've got x left. And here we get, for our x, 33 divided by -32. We can write this as x equals -33/32. So that would be our final result. Now, here the trick really is that we substitute this initial expression here in the denominator by something. Try to solve for this substituted expression like we've done here, in this case here, where we calculated this y, and then put in what we put for y and solve this equation again for x. It's a little bit complicated, but it gives a nice example how we can use these different operations and inverse operations to solve a fairly complex term like this one. I hope this makes sense, and thank you very much for watching.